Okay, so for this question, they're asking us, let's see, we want to estimate how big a sample, so it's a sample size question, that's why I chose this. So how large of a sample is required if we're going to know past on previous evidence, we know that 38% of some population has some genetic marker, right? And so we want to get, and so usually what happens, you did another sample, came up with a confidence interval, and the margin of error was too big. So what we want to do is how big a sample do we need to take in order to have a margin of error that's within 1%? Here, let me get, so it's within 1%. You see that? So I know this old estimate of P, right? That's our, we think that's our population proportion, or it's based on another sample. They'll say it's P hat, a sample proportion, and we want to come up with a 90% confidence interval. So what we're going to do is, you see this formula here in Dr. Stevens' textbook. It says if you know an old estimate of p hat, this is how you calculate the sample size you need. And now the other thing we got to worry about is 90% confidence. So let me wait a minute here and let me pull up a copy of that table out of the Dr. Stevens textbook. So in that T table that I gave you, or it's in the back of your textbook, if you bought the textbook, you see these common critical values of Z. These are the values you're going to use. Now, there's a couple of other ones that come up here, but Dr. Stevens certainly has it. One thing you might want to add just now, because I know on the handout that I'm giving my Oxbow students that I asked them to find a 98% confidence interval, and that works out to be 2.33, a z-score 2.33. Now I can show you that on this z-score table, or I mean, you can use that David Lane applet if you want. If you go in here, let's see. So if we have a 98% confidence interval, that means we're going to catch. There's a 98% chance we'll catch the population proportion, and that means he's 2% outside that. So there's 1% above it and 1% below it. So that means the probability less than that z-score, whatever that is 0.01. Sorry, I'm trying to do 1,000ths. 0.01. So what we'll do is we'll go into our table here and we'll look as close as we can get to 0.01. Right here is pretty darn close. You see that? So it's in between it's in between 0.02 and 0.03. So if we go with it's one away from so that what that tells me is that's a little bit more or a little bit less than the 1%. And because we want to make sure we catch it, we're going to go err on the caution, err on the side of being over, using too much. That's why I said it's the z-score is 2.33, because that'll definitely catch it. A 2.32 is not quite big enough, right? See, that's just a little bit more than 1% below it, right? So that's why we go with 2.33. Now, I'm going to show you this because I know certainly if you've watched my other videos or if you're an Oxbow student, I've been directing you here right along. And if you use David Lane, that z-score table here, and we're going to go value from an area, because we know our area to the left is 0.01, mean and zero standard deviation, well, and I want below. You see how that rounds to 2.33? We could also go area 0.98 and then go between and see how that gives us the negative and the positive. 98% of the samples will fall in that range. Sample proportions will fall in that range, which tells us that 98%, there's a 98% chance the population proportions in there, or that'll capture that. Okay, so that's the only other thing that comes up. So if you have a copy of this table, and I would recommend you write the 98% confidence intervals, use 2.33. Okay, so now let's come back and do some math here that I was going to show you. Let's see, I'm going to clear all my writing. And let's come back and look at that problem. Let's see, where was it? It was a MyOpen Math problem, wasn't it? Here we go. Here's that. So we want to come up with a 90% confidence interval that's within 1% of the true population, with using the old value of the old estimate of p hat, or p as being 0.38 or 38%. So let's see. I think that was here. That was here, wasn't it? No, it was in Word. That's where I had it. And let's see, let's cancel this. Let's open this up. Here we go. So I want to be a 90% confidence interval. And if you look at that, Z-score table, you see a 90% confidence interval, you're going to go 1.645 standard deviations either side of the mean or the proportion. So we'll come back here, and it tells me to take that critical value of Z. See, that's all that means, is what Z-score to use to catch that margin of error, to catch that level of confidence. So I'm going to do 1.645 and square it. And then I use the old value of p hat, or the old estimate. So, and that was 38%, so 0.38. And then Q is 1 minus p hat. So that's going to be what? 0.62. I did 1 minus 0.38. Those don't get squared over the margin of error squared. And I think it said 1%. Well, I want to be within 1%, right? So let me come back and double check that. Come on. Yeah, I want to be within 1% of the true proportion. So that means I'm going to do 0.01 squared. Okay, I don't want to clear that. I just want to come back here. So this is white. So you can write that down. So now I got to do the calculation. Now you can use a Google calculator. You can use a regular calculator, your phone calculator. I've got a graphing calculator set up right here. And I'm just going to key it in right the way it is. So 1.645. I'm going to square that. I'm going to times it by 0.38. Times that, multiply that by 0.62. Divided by 0.01 squared. When it equals, I get that number. Now, here's the trick. Normal rounding rules would say to go to 6,375 people. But the optimum sample size is 6,375.39, blah, blah, blah. So when you're using this sample size formula, you'll always round up. It doesn't matter what you get, unless you get a whole number. If that was exactly 6,375, no decimals, I would just use that number, but there's that decimal part. You'll always round up. So the correct answer for that problem is going to be 6376. Let's come back and make sure I'm not just blowing smoke at you. 6376, I said. Let's submit it, see if I get it right. And I do. Okay. Oh, interesting. They said, MyOpen Math said 600, rounding down to be okay. Now, I caution you, don't go do that. You want to round up. WebAssign, if you're a CCB student, Math Excel, if you're an Oxbow student second semester, those are always going to expect you to use those rounding rules. We always round up, okay? But that's how we do it.